We're moving into working with rational numbers, meaning we're going to have to operate with fractions. To operate with fractions, you need to have a strong, in-depth understanding of multiples and factors. Most basic definition of a multiple is when you take a number and multiply it by any given integer. So the first multiple of 2 is 2. Second multiple is 4. Third multiple is 6, 8, 10. We learned how to count by twos a long time ago. Here are multiples of 3, 4. Skipped 5, 6, and 7 to go to 8. And then here to 15. If we look at factors, we're now thinking in terms of division. We want to know how many numbers can multiply together to create a given value. So 2 and 3 are both prime numbers. They have exactly 2 factors, 1 and themselves. What we do to factor a number completely is we go down the number line and ask about every single number. So I ask about 1. 1 times 2 is 2. I don't need to ask about 2 because it's already here. I'm done. Same with 1 and 3. With 4, it's our first composite number. We have 1 and 4. Does 2 go into 4? Yes. 2 times, it's a perfect square number. Here we have 1 and 8, 2 and 4. 3 doesn't go into 8 evenly. 4 does, but it's already here. We're done. Here you see all the factors of 15. I'll talk a little bit more about 24 since there are more factors here. We have 1 and 24. Does 2 go in? Yes, 12 times. Does 3 go in? Yes, 3 times 8 is 24. 4 times 6 is 24. I'd ask about 5 and then figure out 5 does not go into 24 evenly. 6 does, it's already here, so I'm done. Here are all the factors of 30. Multiples are very valuable to us because they allow us to add and subtract fractions. The least common multiple is the common denominator we need to put these quantities together to one simpler value. So to find 1/3 plus 1/2, what we're going to do is find the least common multiple of 2 and 3. We have them right here. The first multiple they have in common is a 6. So if I have some quantity here, which I divide in half, and I'm adding it to another quantity that's cut into thirds, it's very difficult to figure out how to put these two quantities together. But if I change this half into sixths, meaning I cut each half into 3 pieces, and I cut each of these thirds in half, I now have something I can compare. So essentially what I did was multiply this 1/2 by 3/3. And then we multiply this 1/3, by 2/2. So that gives us an expression that is equivalent to 3/6, which is equivalent to 1/2, and 2/6. So we see our 3/6 right here, that is equivalent to 1/2. We see our 2/6. Altogether, we have 5/6. Similarly, 1/4 and 3/8. What makes this problem a little bit easier is 8 is our common denominator. It's our least common multiple of 8 and 4, as we can see. Actually, every multiple of 8 is just every other multiple of 4. This next one would be 24, as we see right here. So, another visual model here. This time I'll go ahead and use a circle. Imagine we have 1/4 here, and over here we have 3/8. So I'm going to make fourths, and I'm going to cut those fourths in half. So now we have 1, 2, 3/8. Less than a half, but more than a quarter here. So what I'm going to do to make a common denominator is multiply this by 2/2. We now have 2/8, which is equivalent to 1/4, as we can see here. We're going to add those 2/8 to these 3/8, and altogether